Hello again, grade 11. Now we're going to finish this program 5.5.2, all about the calorie counter. We left off with the on-show event, where we read from the text file into two arrays. Now, the global arrays will look like this. After we've read all the items into the arrays, this is what they will look like. This is what an array looks like in memory. It's got a whole lot of boxes that are numbered. This is Imax, and Imax is going to be the same for both arrays. So Imax will be 1, and then we'll put the Big Mac burger in array food box number 1, and we'll put the calories in array calories box number 1. So if you look at your text file, you read from each line and then separated the two items into these two arrays. Arrays are basically a way of saving a whole lot of strings or a whole lot of integers. Instead of having sfood1, sfood2, sfood3, and sfood4, and like a whole lot of variables called sfood and a number, or rcal1, rcal2. We don't want to have hundreds of variable names, so we can just use one variable name and have a whole list of things inside that variable name with different boxes allocated to each one. And now we call these two arrays parallel because the Big Mac burger in box number 1 has 600 calories, which is found in box number 1 of ARR calories. The medium pizza in box number 2 has 1,800 calories, which is also in box number 2 of ARR calories. So they are called parallel because their box numbers are linked. If you can see, this is how it looks like in memory. And of course there'll be more food items and their related calories over there. But you don't, as I said, you don't have to know that now. We'll do arrays later. What we're going to do now is finish this program. We're over here. When we're in the form on-show event, we're reading from the text file, okay, like we did. But now, inside, while we're reading each line, the food, they said, we must put into the list options list box. So we've got to add that food item to our list item, list options, the list box. Very similar to previous activity we did. There's our list box. Looks like a red cheddar, but it's not. It says list options. It's items.add we're going to use for that. This is all in the on-show event. So when we read a name from the text file, like Big Mac burger, that one we want to go and add to our list box. So let's go and do it over here. Sfood is there, not so. So we get sfood and we say list options dot items dot add sfood. So that's going to be added as the first item in the list box. And then we delete sline and we get the rcal. We're not going to add the calories to the list box. We're just basically going to add it. Here is where we create all the items inside these two arrays by using Imax as the box number for both of these arrays. Okay, so we'll know we'll have an array of food and an array of calories, and they'll have box numbers will be matching. So box number 1 in AR food will be matching, be linked to box number 1 of AR calories, just like I'm showing you here. Okay, that's just a quick array explanation. So don't panic now. After we've done all of that, they said we must load the image into the image graph, and they've given us the code there. So yep, you know what I'm doing is I'm copying and pasting. I know it's bad, but it's not really. We're saving time. I'm graph.picture.load from file naught.jpg. So we're putting the first graph, the first picture into our image. So they say we must save and test the program. Rightio, so I'll save it. File, save all, test, run the program. Now we've only written code for the on-show event, and that's what it'll look like. So we've done all of that. See, those are the items from the text file, which we copied into S food and we add it to our list box. So this is the list box, and remember when you click on one, it's going to have an item index, which we will use to get the actual name of the food. And this button, I ate this. Let's see what happens next. Alright, so go to the next one. Based on the range of the percentage. Okay, yeah, okay, we got this I ate this button. Extract the item index from the food item selected. Yes. So in the I ate this button, we're going to go and get our item from our list box. Remember I showed you how to do that. So I'm going to make a variable called S item, and S item will be our LST or is it options? Options dot items square brackets LST options dot item index. So that's a quick way to go and get the items, the item name, and I showed you that in the previous video, so we won't carry on with that. So, and we're going to use our food array, AR food and AR calories, to add the food item and its calories value to list boxes, list food name and list calories. So if they choose that food name, we're going to go and get that particular item. Although they said use the item index, well, we can't actually use the item index because that is naught. If we choose 1, you look carefully. I know I've got the name of the food. I didn't use the item index property of the list box, but remember item index starts at naught. Now we do know when we run the program, this is what's going to happen. We have the items, and that Big Mac burger is naught, medium pizza is 1, green salad is 2. But in our array, Big Mac burger is 1. So if we choose Big Mac burger, we've got to add 1 to the item index. So they tell, yeah, it's a good idea to use the item index and not the actual name of the item. So let's do that. So we won't use the actual name of the item. So we'll just use I chosen colon integer. And we're not going to use the string, we'll use the item index. Our chosen will be equal to the item index of the list box, but because the list box starts numbering at 0 and the array starts numbering at 1, we add 1 to it. How do we know the array starts numbering at 1? Well, here's the thing about the array. They declared the array over there and they set it equal to 0. Normally what you do is we set them equal to 0 in our onActivate event. So I'm actually going to do that. Our max and our total calories. Remember counters and totaling variables, because that's what they are. This our max acts as a counter, and our total calories is a totaling variable. We always have to initialize them to 0, and the best place is on form activate or form create or form show, and our total calories equals 0. So I'm doing that inside my form on show event. Right, so I've done that, done it in the on show event, which is the same as on create or on activate, doesn't matter, you can use either one of those 3. We've done all this other stuff, we've incremented out, we set to 0, our max is now set to 0, and here we increment our max and it will start at 1, won't it? The first time we read from the text file, our max will then be 1. We set it to 0 there, and this while loop is going to carry on reading from the text file. There's the text file until it gets to the end, it reads the last line, and that number Imax will then be, it'll be 1, 2, 3, 4, 5, 6, 7. Imax will be 7. But if we choose the Simba chips from our combo box, run the program and we click on Simba chips. Remember the Simba chips was 7 in there for Imax, but over here it's going to be 6. Because that's 0, 1, 2, 3, 4, 5, 6 for the item index. So we're going to use that. That'll be a clever thing to do. To use that right in this I ate this button, and we choose the item index plus 1. So our list options dot item index, add 1 to it, and then we'll have the right number for the array. So ARR foods box number I chosen is going to be our item index that we have chosen, and it'll be the corresponding food because we've added 1 to whatever the item index is. Remember, over here array starts at 1, and in the list box it's going to start at 0. Okay, let's get on there. It says we must use the item index to add a food item and its corresponding calorie value to list boxes. There's 2 other list boxes, so we've got to use the food name and the calories to a list box called list food names and LST calories. LST food names, LST calories, LST. Yeah, they are. There's LST food names, LST calories. So in this, we're going to add it to those 2. So LST food name dot items dot add open brackets, and in brackets we'll put our array name because that is going to be a string. If you want, I will rather do this. S food chosen colon string and rcal food chosen colon integer. So what I'll do instead, just to make it easier for you to understand, S food chosen will be equal to the array food box number I chosen, and then all we have to do is go and put S food chosen inside here. Okay, so we'll get the chosen index, item index. This time we're not going to look for the string from our list box. Oops, I've got an error. Okay, LST food, OS food chosen. I think that's right. Let's hope so. I'm going to run the program again. Oop. Right, I've got the names wrong. LST food names. Food names. Right. Okay, so we run. We're gonna choose a food from this list options. This one. You choose that one, and then we're going to read the item index in this button. Click here, and then we're going to add that food to this list box called LST food names. But we also got to put the calories over here, the corresponding calories. Remember, I told you that the 2 arrays are matching, so box number 1's food will have box number 1's calories and AR calories. Well, that's the whole concept that we are dealing with here with these parallel arrays. Anyway, what we're doing, the thing was that I ate this box is going to go and take the chosen food and go and put it into these other 2 list boxes and the corresponding calorie in this list box over here. And we do list.items.add. We're using r chosen as an integer, which will be the item index of this list options box. We add 1 to it because, like I said, the list options, the list box starts at 0 numbering, but the array is going to start at 1. And then I'm going to get the corresponding food from AR food using that box number. Take note, we use square brackets to refer to the box numbers of the arrays. So R chosen is going to be sitting in there. We'll have the right number. And then the food name, or S food chosen, is going to be added to the list box. And then we have to say LST, the calories dot items dot add. We're going to put the corresponding ARR thing, but how are we going to get it? rcal chosen, lcal of the food chosen will be equal to ARR calories square brackets are chosen So we get the corresponding one from that array. So we get our chosen, use it over here to get the food name, and use it over here in the AR calories. Is it called AR calories? I hope so. Yeah, I think it is. We get the corresponding calories, and it's an integer. This array is integers, this array is strings, and then we add the calorie chosen. But remember, this rcal food chosen, we can't add an integer to a list box. We have to convert that to a string. And we must make sure we have our brackets. Int to string. So that food chosen, rcal food chosen, is an integer. Take note, there it is. Always keep track of your variables and their data types. If that's an integer, you have to convert it to a string if you want to add it to the items of a list box. Moving on. Right, so we've added to list calories. Now increment the variable r total calories. So we're going to add up our total calories using that I calories, rcal food chosen. So we're going to say our total calories, our global variable called our total calories, where it is. Where is it? Sorry, there it is, our total calories. It's going to be equal to the previous R total calories. Where am I? There we go. It's going to be equal to the R calories will be equal to the previous R total calories plus this calorie of food chosen. So each time we click I ate this box, this is what's going to happen. A button, sorry. Each time we click the I ate this button, this is what will happen. But we also have to get the percentage of calories consumption. And we're going to update our graph depending on what that percentage is. And basically that's for that button click. And then after that we'll have the reset button and the add button. But don't worry about that. We're going to do the I ate this button. So we incremented our total calories by the calories, and then we're going to get the percentage of calories chosen. The calories extracted from, so we want to know all the total calories by the calories consumed, okay? Then calculate the percentage of calories consumed using the following equation. So they say we must use this equation here. We're going to divide by 2000. So they're not telling us to guess what that number is. So we have to go and calculate a percentage. Now I better go and declare a variable, hey? R%. I can't just use percentage. I've got to use R% equals, colon equals, our total calories divided by 2000 times by 100. I must go and declare R% up here. Then, next thing, load the relevant graph image dependent on the range of our percentage. So, our percentage is going to be a certain number. And we have 0%, 20%, 40%, 50%, 60% for all those different numbers. So if the range from 0 to 20, refer to the graph, okay? Refer to the graph image file names. So we're going to go and look at our file names and have a look. We've got from 0, if the calories is greater than or equal to 0 and less than 20, we were going to have that. So what I'm going to do is convert my calories to integers. This R%, I want to convert it to an integer. I'm going to round it just to make it easier, okay? R%. I don't want if then else statements, a whole lot of if then else statements. Rather say R% equals, and I will round it, R%. End of story. I won't trunk it. I suppose I could trunk it, which means getting rid of the decimal points, and then we don't worry about, you know, parts of a percentage. Well, maybe trunk will be more accurate. No, round is better. It's better to have more calories than less calories, and you'll be more careful. So we say case I% of 0 to 19. We'll do something. 22, what's the other number? 2239. Oops. 39, we'll do something. 42. You've forgotten about these things, eh? Case structures. 62. The other percentage will be 80 and then 100. 62, 79, and then 80 to 90 to 100. So we're going to do things for all those options. So case is much neater, looks better than if then else, if then else, if then, you know. It's not do if then else, nested if statements, very messy. So we're going to load the relevant graph image into our image called, and we did write code for that earlier. Let's go and copy and paste that code. There it is, load from file. See why are we copying and pasting? Well, because it saves time in exams. And then of course we just load the 20 graph, the 40 graph, the oops, am I wrong here? 0 to 19, 20 to 39, 0, 20, 40, 60, 80. Oops, there was 100%, wasn't there? Was there 100 graph? There sure was. 79, 0, 20, 40, 60, 80, 60, 0 to 19, 60 to 80. Yeah, right. We got a bit of an issue here because I obviously don't know what I'm talking about. So from 0 to 19. Okay, if it's 0, okay, fine, 0. Let's rather do that. If it is 1 to 20, and then we'll load the 20. If it is 21 to 40, let's do it this way rather. If it is 41 to 60, we'll load the 60% graph. If it is 61 in that range, 61 to 80, we'll load the 80% graph. And then if it is 81 to 100, we'll load the 100% graph. Anyway, you get the idea. Okay, so that's that instruction done. So update the calorie counter. Ooh, right, we've done that. Now we're going to do the next one. Update the calorie counter in LBL calories label. So our calorie counter, total calories, must go to the LBL calories label, and the counter percentage and LBL percentage. So we haven't finished yet. We have to go and do the following. Okay, this is the procedure here. Remember, case has only got an end and no begin. So LBL calories dot caption must be equal to int to string I total calories. Remember that calorie counter is our total calories, which is a global variable. It's not local, nope. But our percent is not a global variable. But should we make it a global variable? I think we should, because we've only got it at local. Oh, no. Let's leave it as local. LBL percentage. Okay. LBL percentage dot text, and don't forget we'll use the integer version, I%. Remember, I rounded it to I%, and that's that. So we can run our program quickly, find the errors, dot caption, not text. Label has a dot caption property, not a text property. Right, so now we're going to choose what we ate, and as you can see, the calories are adding up, and we've got the 150 is the calories, 8 is the percentage. But if I choose that, now that percent actually should change. So I think R% and I% should be global variables, because you know it should be percentage of 2000 calories each time you add up. So let's go and make them global. All you do is cut them out of here and go and slot them in over here. And there we go. Now we'll see that will be fine. But let's move on to the next activity, the next part of this. The reset button. Clear all items in the list food names and list calories list boxes. Right, so this is the reset button. Reset. We're going to clear all in the list boxes. Which ones? List food names and list calories. As I do it, list food names dot clear. That's it. And LST calories dot clear. That's what we do. Easy peasy. Assign our total calories to 0. Our total calories equals 0. Then load the image, the 0 image. Copy and paste, guys. I'm going to load this image, 0.jpg, so we do that fast, and you can finish your programming quicker in your exam. Display 0 divided by 200 in the LBL Carol's label and 0% in the percentage label. I forgot to put a percentage sign in the other one, didn't I? Alright, LBL calories dot caption equals, we actually wanted to make it 0 out of 2000, 0 out of 2000 calories, and LBL percentage dot caption equals 0%. Well, that means that when we displayed it previously, we should have actually put a percentage sign at the end of it and done all of this stuff as well to make it look pretty. We'll do that just now, and yeah, we'll do it right now. Actually, it's not so difficult. Just add here to our calories, and we're going to add that a percentage sign to the end of that, like such. There we go. Now, next thing. Okay, we test it and see. So, Big Mac burger. I ate this. Coca-Cola. Yeah, I ate that. So we're adding up our calories here, and that is 38% of 2000. So there we go. Reset. There we go, and then we can start again. Right, now we're going to go to the next thing, add button. Extract out of EDT food name and EDT calories. Okay, there's 2 calories here. There's 2 edit boxes here, EDT food name and EDT calories. We're going to add a new food name, and this is where we're going to write to text file. So EDT food name, EDT calories, we're going to go get that input, and I'm going to call EARS food colon string. Doesn't matter if I used S food in another one, but if I used S food as a global variable, then I cannot use S food yet. Okay, there's no S food over there. So, and we did remove those others, yeah. So sfood and rcal, I can use it because it's not global variable. If it's a local variable somewhere else, yes, we did use it somewhere else, it doesn't matter there, because when this button click event is finished, those variables will all disappear and you can use the same names elsewhere. When this button click here is finished, then those names will all disappear from memory. So sfood will be equal to edt food name dot text, okay, and then rcal will be string to int edt calories dot text. I'm just guessing on those edit box names. Now we can see what else we must do. All right, add that data to the text file called food.txt with a comma separating it. So we're going to go and add a line to this text file. It's going to look the same as this and a comma separating. So we'll do that, but we will assign file, and we've got to use the text file variable. So I'm going to put one in here, t file. It's not used globally, so I can use it here. T file, it's not used globally. Sound file t file. Food.txt. Now, the question is, we actually only want to do that if the file, well, we have to go and check if the file exists, because that's what we have to do. If not, file exists. Food.txt, then begin and end. Begin. Because we want to write to it, we're going to rewrite. Well, we'll first assign file and then rewrite. The assign file, we'll use the assign file statement, and then we will rewrite t file. Okay, else begin and end, and we've done this a couple of times, so I'm quite sure you know now. Else, if it does exist, we will put it in append mode. Append t file. Now for both instances, we are going to write a line to the text file, so we'll write our statement write ln t file. We're going to put in sfood and join that to a comma, and then join that to end to string ical. And then we will close file t file. So we'll do that in both instances. So there's a bit of revision for you. We've done this before. Then the next thing is add the food name to the list options list box. Okay, fine. Right. The food name, so lst options dot items dot add is food. We're adding it to our list box options, and we're also going to increment rmax and add the food name to that array and to the calories array. So we have to increment rmax, increment rmax, and then we're going to say AR food square brackets rmax will be equal to sfood, and ARR calories square brackets rmax will be equal to ical. Calories has got integers in it, AR calories integers, AR food strings, so we're good there. Save and test your program. Fine. I'll save all, and we finished. Now you can do this by yourself also. Let's see, what have I done wrong here? Oh, I forgot to put a bracket. Remember, there's two parameters for writing a line. The one is the text file variable, and the second one is the string. And we built a string with sfood and a comma and an integer converted to a string. 1, 2, 3 things make up this string that we're writing to the t file which is food.txt. I'm running the program. And this was a long haul, wasn't it? What do I feel like? Okay, that. Let's say we want to add peanuts and raisins. Peanuts and raisins. I don't know how much calories that is, you know, it's a bit tricky. I'll make it 100. A lot. Okay, add it. Oops, input output error. Input output error. Append T file. Run program reset. So this append statement, which was bombing out over there, food.txt, okay. Oh, you know what it is? Our text file, we should actually close it after reading from it, just in case. Alright, let's close it, even though it's a local variable. So when we read from the text file, in the onShow event, here it is, form show, after you read from the text file, okay, read line, let's go and close it after the while loop. Close file, open brackets. It's also called T file. See, maybe the processor didn't like me using the same name, even though they're in different procedures. I'm doubting if that's the error, but we shall see when we run it again. Right line, T file, append. So sound file is fine. Right, everything else looks okay there. I'll save all unless. Okay, let's have a look. So we're going to try this. Peanuts, or let's make it raisins. Raisins, and let's make it 20 calories because they add. There we go. So that was it, just because of the close file statement. So when in doubt, use a close file all the time, after you read and after you write. And we'll see you on the next one.